Hello viewers, in today's class we are going to solve some questions on image of a point in a plane. So the topic of this lecture is to find the image of a point when the equation of a plane is given. So here we have to find the image of the point having position vector I cap plus 3j cap plus 4k cap in the plane r dot 2I cap minus j cap plus k cap plus 3 equal to 0, right? So here the vector equation of the plane is given, and let us first convert this vector equation into Cartesian form. So we know that the vector r is xi cap plus yj cap plus zk cap. So if we take the dot product of this vector and this vector, we get 2x minus y plus z plus 3 is equal to 0. So this is the equation of the plane pi, and the point is given as 1, 3, 4, and we have to find the image of this point. Let us call this point as A, and we have to find its image under this plane, right? Now let us take this plane pi and let this point be at this point, this place, that is 1, 3, 4. Now we have to find its image, and we can treat this plane as a mirror, and the image of this point A, it lies here, and let this point be B, right? So B is the image of the point A, right? Okay, so let the coordinates of this point B be alpha, beta and gamma, right? And we'll treat this plane as a mirror, right? Now let this line AB, this crosses this plane pi at this point, say this point be M, right? So M is the point where this line AB crosses this plane pi, right? Okay, now M is the midpoint. M is the midpoint of AB, right? So by midpoint formula, the coordinates of this point M can be written as this is 1 and this is alpha, so we can write it as 1 plus alpha divided by 2. Then we have 3 plus beta divided by 2 and 4 plus gamma divided by 2. Now this point M, it lies on this plane, so it must satisfy the equation of the plane. So here substituting this point in the equation of the plane, x is 1 plus alpha by 2, y is 3 plus beta by 2, and z is 4 plus gamma by 2. So let us substitute this point in the equation of the plane. So let us see what we get. So this is 2 times 1 plus alpha by 2, then we have this is 3 plus beta by 2, and then we have 4 plus gamma by 2 and plus 3 equal to 0, right? So here if we simplify this, we get 2 plus 2 alpha minus 3 minus beta then we have 4 plus gamma plus 6 and equal to 0. We can multiply this whole equation by 2, right? Okay, so we have got 2 alpha minus beta plus gamma, and this is 4 plus 2 6 plus 6 12, and 12 minus 3 is 9, right? So let us call it equation number 2, right? Okay, now the normal to this plane, right? Let us take this vector as the normal to this plane, and this is n cap, and the direction ratios of the normal vector, right? The direction ratios of the normal vector to the plane are given by the coefficients of x, y and z in the equation of the plane. So here the coefficient of x is 2, so the dr's of the normal vector are 2, and we have then minus 1, and here we have 1, right? So these are the dr's of the normal vector, right? And if we take this line AB, right, this line AB is parallel to the normal vector, right? This line AB is parallel to the normal vector, and we know that if two vectors are parallel, then their direction ratios are proportional, right? So we can apply the condition A1 by A2 is equal to B1 by B2 is equal to C1 by C2, where A1, B1, C1 can be taken as the direction ratios of the line AB, and A2, B2, C2 can be taken as the direction ratios of the normal vector, right? So the dr's of, now the dr's of line AB are given by alpha minus 1, because if we have a vector joining 2 points x1, y1, z1, x2, y2, z2, then the dr's can be written as x2 minus x1, so we have alpha minus 1, then y2 minus y1, that is beta minus 3, and then we have z2 minus z1, so we have gamma minus 4. Now these two dr's must be proportional, right? So we can have alpha minus 1 divided by 2 is equal to beta minus 3 divided by minus 1, and then we have gamma minus 4 divided by 1, and let us take it as lambda. Now taking alpha minus 1 by 2 is equal to lambda, so we have alpha is equal to 2 lambda plus 1, and taking beta minus 3, taking beta minus 3 divided by minus 1 is equal to lambda, so we have beta is equal to minus lambda plus 3, and gamma can be written as gamma minus 4 divided by 1 is equal to lambda, so gamma can be taken as lambda plus 4, right? Now see, here we have obtained the values of alpha, beta and gamma in terms of this scalar lambda, right? And substituting these values in equation 2, we get, see, this is 2 times alpha, alpha is 2 lambda plus 1, then we have minus beta, and minus here beta is minus lambda plus 3, and then we have gamma, and gamma is lambda plus 4, and here we have plus 9 is equal to 0. Now this is a linear equation in one variable, that is the scalar lambda. So here we have, if we simplify it, we get 4 lambda plus 2 plus lambda minus 3 plus lambda plus 4 plus 9 is equal to 0, and this is 4 lambda, 5 lambda and 6 lambda, right? So we have 6 lambda, and this is 2 minus 3 minus 1, this is 9 plus 4 13, so 13 minus 1, that is 12, equal to 0. So 6 lambda equal to minus 12, so lambda is equal to minus 2, right? So once we have obtained the value of lambda equal to minus 2, we can substitute it here. So alpha is equal to 2 times minus 2 plus 1, beta becomes minus of minus 2 plus 3, and gamma becomes minus 2 plus 4, right? So this is minus 4 plus 1, that is minus 3, and this is minus minus plus, so this is 3 plus 2 5, and here we have 4 minus 2, that is equal to 2. So therefore the values of alpha, beta and gamma are calculated like this, and the image of this point A under this plane is given by minus 3, 5 and 2, right? And if we write it in the form of vector or the position vector, we can write it as minus 3i cap plus 5j cap plus 2k cap, right? So this is the image of this point under this plane.